Okay, this is the first of three videos around why conjugates are important and why are calculus teachers obsessed with conjugates when it comes to um, imaginary numbers. So the first thing I want you to see is that if we've got an imaginary number z, we show that its conjugate is z bar with that z above, and notice the real parts have the same value, the imaginary parts have opposite signs but an equivalent size. So all we've done is we just swapped over those signs. So why is this important? Okay, well, the first thing I want to do is I want you to just see how conjugates come from using the quadratic equation that you all know and love. So let's just say that we've got x squared plus 10x plus, 34 equal to 0, right? So if I'm going to try and solve that using the quadratic formula, I would go minus 10 plus or minus, what is it going to be? The square of 10 minus 4 times 1 is the coefficient of my x squared there, times 34 all over 2. Okay, where am I at now? So then I'm going to have, let's work this out, minus 10 plus or minus 34 times 4 is, what am I going to get? 16 plus 120, 136. Is that right? Oh, yeah. But then I've got to take that away from 100. So I'm going to get negative 36. Okay. Oh, yeah, that's right. Well, I'm doing imaginary numbers, so I'm no longer upset when I see negative 36 in the brackets inside the square root there. So what have I got? I've got essentially there, I've got minus 10 over 2 is my real part, plus or minus negative 36. Oh, hang on. Let's not write it like that. Let's just write it as the square root of 36 times I all over 2. So that's my imaginary part. Okay. And then I can say, oh, well, that's minus 5 plus or minus 6 over 2 is 3i. Okay, so those are my two roots. Notice that one of my roots is going to be minus 5 plus or minus, oh, not plus or minus. One of them is going to be plus 3i, and the other one is going to be minus 5 minus 3i. And what do we notice straight away? Oh, look, he told us this was a video about conjugates, didn't he? Okay, so these two numbers are conjugates of each other. So, this is always going to happen whenever we have an imaginary solution here. Well, okay, if all the coefficients on our original quadratic equation were real, then if we get an imaginary solution, what you can see is that it's coming from the square root sign. That's where the imaginary part is coming from. And notice it's got a plus and a minus in front. So obviously one of your imaginary parts is going to be positive, the other is going to be negative. Okay. If I were to start putting i's in my original equation, I could get all sorts of fancy things, but that will not happen on a level 3 course, even at scholarship. Okay. Now, obviously, that's not the only things that can happen coming out of your quadratic equation. There's a couple of others that can happen. Obviously, if our discriminant is positive, we still get two real solutions. If our discriminant is 0, then we get 1 repeated real root. So let's just say that root was 3, then one of my two brackets when I factorize would have to be x minus 3. If I put another bracket on there, then I'm going to get another root, but I said that my discriminant was 0, and so I'm only allowed to have one solution, so it's got to be the same solution for that bracket as well, otherwise I'm going to not be getting that discriminant of 0. So it's a repeated real root. Obviously that could be done with a squared instead of writing the bracket twice. Okay, and our final situation here, if the discriminant is negative, then what we're going to have is 2 imaginary roots. Not imaginary. It's not quite right. They could be imaginary, but 2 complex roots which are conjugates. Conjugates. Now, like I say, on this course you will only ever have real coefficients on your quadratics or cubics or whatever you're looking at, and therefore you will only ever have this. So if you're given 1 root and it's complex, you automatically know 2 roots, and you'll be able to use some of the techniques that I'm going to show you in the future videos. So that's all I wanted to cover today, or at least in this video, unless you go straight to the second video. So please ask any questions below, just in case I haven't taught you something that you need to know.